Hello everyone, welcome to Digital Electronics Virtual Laboratory, and in today's tutorial we will learn how to simulate half adder using XOR and AND gate logic IC. So to access Virtual Laboratory, just Google Virtual Labs and click on Electronics and Communication Labs and then click Digital Electronics Lab. So this is the list of experiments, and today we will perform practical number experiment number 2, that is construction of half adder using XOR and NAND gate, and we will also verify its operation. So this is the window for half adder. So just click on half adder. There are two simulators, simulator 1 and simulator 2. So first we will perform our half adder operation with the help of simulator 1. On the left hand side there is a list of instructions which we have to follow for the simulation of this half adder. First of all, we have to apply 5-volt supply to the IC. Then we have to press switch A and B. This is the on condition of the switch. This one is the off condition. The sum LED glows if any one switch is on out of both the switches, else it won't glow. Okay, same for carry also. So our task is to apply a power supply to this IC. So as I already told you in my first tutorial that how to remember IC numbers, first of all we have to know the IC number of XOR gate and AND gate. So the IC number of XOR is 7486 and the AND gate IC is 7408. In the pin diagram of 7486 IC, the pin number 14 is for power supply and pin number 7 is for ground. Same in case of AND gate, pin number 14 is your power supply and pin number 7 is for ground. There are 4 XOR gates in 7486 IC and 4 AND gates in 7408 AND gate IC. Okay, so a proper connection diagram between these two ICs and the LEDs is already given in this simulator. We have to just apply the inputs by switching on and off these two buttons. So first we have to apply a supply 5-volt across the pin number 14 of both ICs. Then switch on and off your input A and input B. So as we already know the truth table of half, so for half adder there are two inputs A and B and two outputs sum and carry. So for two inputs there are 4 possible combinations from 00 to 11, and for two inputs 00 the value of sum is 0 and carry is 0. For 0 1 the output is 1 and 0. For input combination 1 0 your output is 1 and carry is 0. For 1 1 your sum is 0 and carry is 1. So when we solve this expression for sum, we will get it is equal to A XOR B, and for carry your output is A dot B. So simply we have to implement sum with the help of XOR gate, and we have to implement our carry with the help of AND gate. Okay, so in simulator 1 we are using two ICs of XOR gate and AND gate. Simple. So 1A, 1B, we are applying input. Across 1Y, we are taking our output. Same way, for AND gate, we are applying our input across A and B, and through Y, we are taking or we are getting our output. Okay, now we have to apply our condition. So first 0 0. So for condition 0 0, your sum is 0, your carry is 0. Now condition is 1 0, so add it. So your A is 1, B is 0, so sum is 1, carry is 0. Second condition, A is 0, B is 1. Add these values to your truth table. So for A equal to 0, B equal to 1, sum is 1, carry is 0. And for both 1, for A equal to 1, B equal to 1, your output sum is 0 and carry is 1. So you can check your output with the help of LED. That LED is glowing for output 1 and it is off for output 0. So with the help of this setup, or you can say this, with the help of this beautiful setup, we can verify our half adder implementation, or we can simulate our half adder, or we can check the operation of half adder with the help of these two ICs. In the same way, for with the help of simulator 2, we can check the truth table of half adder, that for 0 0, your sum is 0 and your carry is 0. So you can check with the help of remark. So for 0 0, your sum is 0, carry is 0, so your remark is correct. It means you have applied right logic. If you write sum equal to 1 and then check, then it will give you a remark of incorrect. It means your logic is, or you have applied some wrong values. So this is very easy, and you can check your input combinations, output values with the help of these two simulators. So this is all about the simulation of half adder using XOR gate and AND gate. Thank you.